Welcome to another episode of Tim Talks, where we talk shop. Today I'm with Jason Mann, and we're going to talk about a little bit about our plastic molding design, and what are the things that go into when you're designing a plastic part. What are the things that people should consider that impact cost, lead time, things to stay away from when designing a plastic part? Just common knowledge that we have resources of and want to share those with the folks who are watching.
Sure. So from a design perspective, there's a couple things you want to take into consideration to try to make sure that you end up with the best possible part you can and don't get into a bad tooling situation. So a couple things to consider from a design perspective. In the tool, you want to think about parting line locations. You want to make sure that that parting line is going to end up in a place that it's not going to be aesthetically pleasing. You also want to make sure that you don't end up with a situation where you've got undercuts and things of that nature based on the part geometry. So parting line location is very important. Another important aspect to consider is undercuts. You want to make sure that in the design of that part, you try to eliminate as much of the possibility for trapped steel conditions as you can. So you don't want that plastic to flow into a part of the mold where it can't be relieved through straight opening and closing. You can add slides and things of that nature to alleviate undercuts, but you want to try to avoid those as much as you can. Draft is something that's very important. So you typically want to have about 1 degree of draft per linear inch in the direction of draw. That can change depending on the texture involved. The deeper the textures, the more you may need to allow for draft. So it's definitely not something to be overlooked. Oftentimes people won't consider that till the back end, at which point it's too late because it starts to affect the overall design of the part. So you really want to give that some good consideration on the front end. Wall thickness, again, very important. You want to try to maintain nominal wall thicknesses as much as possible. When you go from a thick to thin condition, you start to affect the material's ability to flow through the part effectively. And you can also end up with some undesirable sinks and things of that nature.
Warpages, stuff like that.
Yeah, you get all kinds of undesirable effects from a molding standpoint if you have different non-uniform wall thicknesses. Bosses are very important. It allows you to put inserts into the parts, use self-tapping screws. You can also use those as fastening mechanisms. So they provide a really important structural element to the part. But you have to be very careful because if your diameter exceeds 60% of the wall thickness, you can end up with sink marks on the exterior of the part, which cosmetically can be a very bad thing. So special care and consideration has to go into bosses and the design and location of those bosses so you end up with the best possible part. Ribs, similar to bosses, they can be used from a structural perspective. That can also be used as a method to improve filling of the part as well. But again, you want to try to maintain those wall thicknesses to less than 60% of your outer wall thickness so you don't end up with sink marks and undesirable cosmetic effects. Radii and corners, very important. So in nature, you'll notice there's really no straight corners and edges in nature. That's due to the fact that bends and curves lend to stronger elements. So if you look at a tree where the trunk of the tree meets the branch of the tree, there's a nice radius and a curvature that allows for better strength. It's no different in plastics. So you want to make sure that you use corners or avoid sharp corners and edges and add radiuses wherever you can to lend strength and also to allow for better filling throughout the part itself. Material shrink, something that's very tricky on the front end of building new tools. You always want to make sure that in building it, you get the right shrink rates. Plastics are going to shrink over time. It's important in the mold design, but then also in the final part. As that part comes out of the press, it's going to continue to cool for a period of about 24 hours, depending on the material and whether it's got any fillers. So you want to make sure that the conditions in which it cools on are well maintained. Vents, really in the tooling, you want to make sure you've got proper venting. That's going to allow the gases at the front of the fill to be able to escape the tool and not get trapped so that you don't end up with cosmetic defects and you don't end up with knit lines or weld lines where you don't want them. Knit lines and weld lines are also important to try to eliminate from both cosmetic and performance standpoint, where that plastic wants to come back together and weld back to itself. At the front of those flow fronts, you can have gas and contamination, and if it doesn't have the ability to escape the tool, it's going to get trapped in there and you have a weak weld point or a cosmetic blemish. So you want to try to avoid that as much as possible, and you typically want to make sure that tool is well vented to be able to do that.
Man, what a great summary from our design guide. So we have some of these resources on our website. So if you go to our website, texasinjectionmolding.com, under resources, there's a plastic injection molding design guide that gets into a little bit more details and can be a resource for you to use. So thanks for joining us for another episode of Tim Talks, and we'll look forward to you next time.